Polymers. We are going to discuss addition polymers. So first, we need to understand what are addition polymers. We know that polymers are made up of basic units called monomers. When a polymer is formed from the monomer, okay, it undergo a type of reaction called as addition reaction, and therefore the name addition polymers. The unsaturated monomers add to each other repeatedly to give addition polymers. The polymerization involves number of interrelated steps. Hence, it is also called as chain growth polymerization. The reaction follows different mechanism, and the intermediate in this addition polymerization form, namely radical, cation or anion. Here we are going to discuss these addition polymers on three important points. First is structure of a particular addition polymer, how that addition polymer is prepared, or we can say the reaction for the preparation, and application of that addition polymer. Here we are going to discuss the addition polymer in which monomer use is either ethylene or a derivative of ethylene. The first addition polymer is polyethylene. Okay? That is PE in short. Structure we can see ethene molecule C2H4 undergo polymerization, and it is written as like this. Okay, we have this polyethylene structure. Next is the preparation. Depending upon the reaction condition used, we get two different types of polyethylene. This reaction can be written like this. In the first, n number of ethylene molecule undergo polymerization, okay, in presence of air at 1500 atmospheric pressure and around 200 degrees Celsius. It gives a polyethylene known as low density polyethylene, also called as LDPE. If the ethylene is polymerized using Ziegler-Natta catalyst, that is titanium tetrachloride triethyl aluminium, it gives a polyethylene known as high density polyethylene. Now let's discuss each of these. First, low density polyethylene, that is LDPE. The properties: molecular weight is around 50,000 to 300,000. Molecular melting point is around 120 degrees Celsius. It is highly branched, so it cannot pack in a particular manner, and it has low density. When we talk about the applications of this LDPE, these are the few mentioned here. It is used in agricultural irrigation, domestic water pipeline connections, wrapping of the food products, textiles, etc. Another polyethylene, that is high density polyethylene. The properties, it has molecular weight from 5,000 to 300,000. Melting point is higher than low density polyethylene, that is 145 to 150 degrees Celsius. It is a linear polymer, so packing of these chain are very efficient, and the density is higher. When we talk about application, it is used for films, for the packaging, for making molded toys, insulation of wires and cables, for the pipes, for the preparation of squeeze bottles, etc. Next addition polymer is polypropylene, in short, also referred as PP. This is a addition polymer formed from propylene when it undergo polymerization process. The structure is like this when we have polymerization of n molecules of propylene. The preparation of this polypropylene can be represented with this. Propene undergo polymerization with Ziegler-Natta catalyst, and we get a stereoregular polymer called as polypropylene or PP. The properties of polypropylene: it is lightest industrial polymer, highly crystalline, and melting point is 208 degrees Celsius. It has high tensile strength, and because of its properties, it has various applications like manufacturing of sheets for television and refrigerators, use in the pipes, films. It is used to prepare wool-like fibers for making carpets, storage tanks, seat covers, ropes can also be prepared by using polypropylene or PP. Next polymer is polytetrafluoroethylene, PTFE. It is also known as Teflon. When all the hydrogens of ethylene are replaced by fluorine, it is a tetrafluoroethylene. It undergo polymerization process and we get Teflon. The reaction for preparation of Teflon: so let's discuss properties of Teflon. The Teflon is the toughest material. It is resistant to heat, acids, alkalis. It is a bad conductor of heat and electricity. It do get decomposed at elevated temperature. It has highest mechanical properties when we talk about the use of Teflon, and because of that it is used in various articles or products. In applications, or important application of Teflon is used for coating of articles and cookwares. We all know the non-stick utensils are coated with this material called as Teflon. It is used for making gaskets, pump packings, wall seals, bearings, insulation for motors, transformers, and coils. Now moving towards the next addition polymer, that is polyvinyl chloride. The most common, we all know that it is PVC. When the vinyl chloride undergo polymerization, it gives polyvinyl chloride. The preparation can be done when we use vinyl chloride in presence of dibenzoyl peroxide, gives the polymerized product known as polyvinyl chloride. Properties: it is a hard material. It dissolves in the mixture of carbon disulfide and acetone. A thermoplastic polymer, it can be molded or remolded by applying heat and pressure. It is formed by the linear chain. It is less crystalline, or we can say it is partially amorphous in nature. PVC has vast applications. It is used for large scale production of cable insulation, equipment parts, pipes, laminated materials for the manufacturing of fibers, raincoats, shower curtains, hospital sheets, photographs, records, floor covering, artificial flooring, etc. Next addition polymer is polystyrene. Styrene, when undergo polymerization in presence of a Lewis acid catalyst or benzyl peroxide, it gives polystyrene. Properties: polystyrene is a linear polymer. It dissolves in the organic solvents. It is resistant to acid and alkalis. It is slightly brittle, or it is easily break down into small parts. So, because of its brittle nature, the applications of polystyrenes are listed here. It is used for the manufacturing of ion exchange resins. This is an important application of polystyrene. Used for making caps for the bottles, toilet articles, refrigerator parts, small radio cabinets, television coils, brush handles, combs, and household articles. So these are the few applications of polystyrene.